Welcome to this year's first Blendini tutorial. Well, Blender has gotten really good at rendering brushstrokes with its grease pencil system, and I kind of want to have that functionality for my Houdini setups as well. Now, I know perfectly well that I could build all of this directly in Blender. The studio is currently proving that with their amazing looking Project Gold. Or even simpler, download the official Brushstroke tools add-on and have all of this pre-built for me. But I'm a Houdini kid. And I also want to use some tools that Blender simply does not have yet. So in this video, we're first of all going to build our own paint system in Houdini and then find a way to bring this data into Blender and render our brushstrokes there. So let's get going. First of all, we need an object to paint, and for this one I'm going to use a 3D scan that you can download for free from exterior.com. And this will be a 3D scan of a mushroom. So to load this in, let's in a geo container drop down a file node. Let's bring up the parameters. And let's first of all select our file, and this will be this fly amanita in the subdiv variant. Now, what specific variant you choose does not matter much. The only thing that I'm caring about here is the point count. So if you want to use a different 3D model, just make sure you have sort of around 15,000 points like this, and you should be fine. Next, let's transform this. Let's make it a bit smaller. So let's drop down a transform node and set the scale to 0.1 like this. Next, let's give our mushroom some colors. So for this, let's use an Attrib from map. And let's load in the texture for our mushroom like this and hit accept. And now we have some point colors on our object. Right now, this is just the standard texture of our model in here. However, to make this look a bit more realistic, we also should add some shading to it, because also those grease pencil strokes won't be able to interact with lights in our scene. So again, we have to do our own shading. For this, I'm going to drop down a point warp. I'm going to wire this in like this. And in that point warp, I want to build something that's called the Lambertian Diffuse, which is one of the simplest lighting methods that you can implement. First of all, I have to define a direction that my light is shining from. And I'm going to do this with a constant. And this in the end will sort of act like a sunlight in our 3D scheme. So on this constant, let's set the mode to vector, and let's define a direction that our sun is shining from. In this case, a value of 1 along the x-axis and a value of -1 along the y-axis. And now to build our Lambertian diffuse, all we need to do is drop down a dot product node, wire in the normal and our constant, and pipe the output into the CD output of our node in here. And you can see some sort of lighting appearing on our object. No, we're not quite there yet. First of all, this lighting is coming from the wrong direction. It's coming sort of from the bottom upwards, which is not realistic. So the one thing that I have to do in here to change this is to go between my constant and my dot product and simply flip this vector by dropping down a negate node like this. And now it's coming from the right direction. And also this effect only works, or really typically works, with vectors with a length of 1. So just to make sure that we're dealing with those vectors, let's drop down a normalize node and let's normalize both a constant and also a normals like this. And one last thing, this is not part of the Lambertian diffuse, but simply something that I wanted to implement because I think it looks a bit better, is I wanted to remap the output of this dot product at least a bit. So for this, let's drop down a fit node, a fit range node. Let's wire this in. And typically I would set this to -1 to 1 and 0 to 1 on the output, because -1 to 1 is what a dot product gives us in the end. However, in this case, to make the shadow a bit stronger, I want to set this to a value of 0.5 to 1, like this. And in the end, what I want to do with this output is not plug it directly into the color output, but I want to use it as a mix factor between two color maps or two color corrections, where I can define a sort of highlight color and a shadow color. So let's do that. Let's build first of all the rest of our node tree. First of all, let's drop down two color nodes or color correction nodes like this. One for a shadow color and one for a highlight color. Let's wire in our CD attribute into both of them. And then also let's bring in a color mix node, where the shadow color in first and the highlight color in second. And then wire in the output of a fit node into the bias. And then let's wire all of that into our CD output like this. And this is our entire node tree done. Now let's actually define a highlight color and a shadow color. Let's bring up our parameters. And for the shadow color, I want to turn down the saturation to a value of 0.8 and the value down to 0.1. And for our highlights, let's just up the value to 2, like this. Now we're done here, we can jump back out. This is our lighting done. And now we can actually work on our brush strokes. But before we actually do directly work on our brush strokes, there's still 2 little things left that I want to do to my object. First of all, I want to smooth it a bit. This will help our brush strokes look nicer in the end. And let's set the strength maybe to a value of 8, like this. And I also want my brush strokes to hover a tiny bit over the surface of my object. And for this, I'm going to use a peak node and set the distance to a value of 0.01, like this. Just make it a bit thicker. And now with this done, I want to bring in the first of those nodes that really I want to use for the setup that just aren't available in Blender yet, and that are sort of the secret ingredient to make all of this work. And this is a node called tangent field. And this is typically something that's used in quad remeshing. And what this does is, if we take a look at this node, and if we highlight this node and jump into our handles tool in here and zoom in, we can see that this node places a bunch of vectors onto each point of our object. And the special thing about these vectors is that they sort of follow the features of our object. So as you can see right here, all of those vectors are sort of aligned with the rim of a mushroom in here, or the stalk in here. And I think this is something that also a painter would do. So this will drive the painterly look that we're going for here. We're done here. This node creates those 4 vector attributes, field 0, field 1, field 2, and field 3. The other thing that a painter might vary is the length of those brush strokes. And I'm going to go for a pretty simple solution in that case. If I have areas with high curvature, for example this area right here, or this one here, or this down here, I want to have short brush strokes because this is probably a very detailed area. And if I have some areas with tiny bit of curvature, like these areas right here or these areas right here, I want to have longer brush strokes. So in the end, I want to measure the curvature and then from that curvature, build a pscale attribute. Let's do this. Let's first of all drop down a measure node to measure the curvature. Let's wire this in and let's again jump into our handles tool to see what we're doing. Let's first of all set the element type to points and let's set the measurement not to area but to curvature like this. And as we can see, this is already giving us a pretty plausible looking result. And to have this exact range in here as a point attribute as well, let's extend our parameters down here and let's set a checkpoint at big visualize range into output. And let's click remap range in here as well. And let's leave it at 0 to 1 like this. Next, I want to blur this as well. Just a tiny bit. Let's drop down an attribute blur, wire this in. Let's set the attribute that we want to blur to curvature. And let's remove the P attribute. And let's set the blurring iteration to a value of 7, like this. And finally, to turn this into a pscale attribute, let's use an attribute remap node, wire this in. And we want to bring in a curvature and write out our pscale like this. And now we can first of all work on this remap range. The only thing that I wanted to do here is reverse it to have very large or very long brush strokes where we do have a very little curvature or very small curvature. And I want to have small brush strokes where I have a lot of curvature like this. And let's also set the output min and output max to look nice, and what worked nice for this object and the scale for me at least was a value of 0.077 as a minimum and a value of 0.549 as a maximum like this. And now we're finally ready to build our actual brush strokes. For this, I first of all want to scatter a bunch of points on my object. Let's set the total count to 3000. This worked nicely for this model. And then let's also create a line, and I want to use that line, or I want to copy this line onto each of those points, create my brush strokes. So on this line, first of all, I want to change the direction. This should go into the Z direction. And I also want to have it centered around the middle. So let's adjust the origin on the Z axis as well. Set this to a value of -0.5. And finally, we want to have some additional points on those lines. So let's set the number of points to say 15, like this. Now, in the end, I want to use a copy to points node in here. I want to wire in my line and my scattered points. The pscale is already working. What's currently not working is our direction, because right now this direction is just a field attribute. However, what this node really wants, or this copy to points node really wants, is a normal attribute. So to turn it into a normal attribute, let's simply drop down an attribute rename, and let's pick one of those fields. One of those field vectors that we want. In this case, I want to have the second field vector, so field 1 instead of field 0. And let's rename this to n like this. And let's also click override existing attributes. And now this looks a lot more like paint strokes. Currently there are still straight paint strokes, so to actually make them curved, let's project them back onto our main object. For this, let's use a ray node. And let's set the mode not to project, but to minimum distance. This works a bit better in that case. And after we're done with that, let's also smooth the output of our ray node. And in this case, let's set the strength to 50. Make this pretty strong. The last thing that I want to do is I first of all want to resample it, set the length to a value of 0.01, and then I also want to have a pscale attribute on all those curves that sort of mimic a paint stroke. So for this, I first of all want to enable a curve view attribute, and I can simply reuse the resample node for this, and this will be 0 on one end of the curve and 1 on the other end. And with this, I can use another attribute remap node, put in curve view as the original name, and again pscale as the output name. Again, let's work on the ramp. Let's put in 1 point in the middle. Let's make it a full value of 1. And let's drop it down at the end again. And let's select all points and set the mode to cat mode ramp to get a nice looking paint stroke. And finally, let's work on the output max. Let's set this as well. And what worked nicely for this model is setting this to a value of 0.015. And finally, to actually see what we built, to get a little preview, let's simply drop down a sweep node. Let's wire our remap into here. Let's set the surface shape to round tube. And let's set the radius to 1. And now this is what our painted mushroom in the end should at least sort of look like in Blender. Before we bring it into Blender, there's one last thing that I want to do. I want to animate my brushstrokes, and this is quite simply done. In the scatter node, under global seed, I want to simply add $f, and now with every frame, I get a new brushstroke. However, in this case, I don't want to animate this every frame, but every second frame. Make this look a little more hand-drawn. So I quickly want to modify this formula a bit. I first of all want to subtract 1 from a frame so that we're starting at frame 0, not frame 1. Then I want to add parentheses around that and divide this by 2 to again have this animate on 2s. And then I want to add parentheses around this as well and round it to an integer by using an int function like this. And now just every second frame our paint strokes will update. Now let's bring this into Blender. The method or the file format that I want to use in this case is an Alembic. So let's drop down a rob Alembic output. And let's maybe save this in the folder of a current hip file. In a new folder, let's call it output or export. And let's call it paint.abc. And let's render the current frame range. And this is currently way too long. So let's set this maybe to 20 frames like this. And now let's hit save to disk. Now once we're done here, we can jump into Blender. We can first of all hit A to select everything and hit delete to delete everything. And we want to bring in our paint strokes. So for this, let's go to File, Import, and Alembic. And let's select the right folder and select our paint.abc and let's import our Alembic file. And we do have some paint strokes now in Blender. Now, we should take a look if all our data that we had on this object has also come through into Blender. So for this, let's go to the Geometry Nodes tab in here. Let's select our object, and we have Blender's version of our geo spreadsheet in here. Let's make this a bit larger, and let's take a look at the control points of these curves that we imported. And in here we have a problem, because Blender, for some reason, still thinks that curves and particles only need a P attribute, only need a position. It does not care about colors or P scales, which is of course a big problem because we spent quite a bunch of time to actually make those look nice and we want to have them in our Blender scene as well, of course. Now, what we have to do to fix this, again, for some reason, is the same solution, the same hacky solution that Manu implemented 3 years ago for bringing particles into Blender. We have to sort of hack the P attribute to bring our other attributes into here as well. And I don't know why we still have to do that after 3 years. Blender, you do have a geometry spreadsheet now. You do have custom attributes now. Just please let us import them via Alembic as well. But for now, again, we have to do the hacky route. And the hacky route, again, will be to export basically one object per attribute and to sort of hack this attribute into a P attribute to make this work. First of all, we'll work on the P attribute. The first thing that I want to do is use an attribute delete node, because again, the only attribute that is traveling from Houdini into Blender is the P attribute, and everything else will just be unnecessary space on a hard drive. So for this, let's drop down attribute delete node, let's select delete non-selected, and on a point level, let's select the P attribute like this. And if you take a look at the info panel now, we just have a P attribute. Then also, currently, if we import this into Blender, and this is just named file1, which isn't really descriptive, so I want to add a name to my Alembic output as well. And for this, I'm going to drop down, first of all, a name node like this, wire it in, and name this, for example, pause for position. And then on the Alembic output, I want to go into the hierarchy tab. I want to say build hierarchy from attribute, and I want to enter my name attribute in here. And now this will import not as file, but as pause, which I think is a lot nicer. This is everything we need to do for our position. Next, let's work on our color. For this, again, we somehow have to turn a color into our position. And for this, again, I'm using a point VOP. Drop this down, wire the output of a remap node into here. And in here, simply draw our connection from our CD attribute to a P attribute like this. And now it's the exact same steps as before. So let's copy our 3 nodes in here. And here, let's change the name maybe to call instead of pause. And we also have to change the file name in here. So let's call it paint_call like this. And let's maybe call the other one paint_pause. Let's now finally work on our pscale. So let's select our point VOP, attribute delete name, and drop Alembic node. Let's copy this one more time like this. Let's jump into our point VOP. And let's not use our CD attribute in here, but let's use a bind node, and let's bind in the pscale, and let's wire the pscale into the position. And now we have this distribution right here. Then again, delete everything but the P attribute. Let's change the name to, in this case, SCL for scale. And let's also update the output path. Let's call it paint_SCL like this. And now the only thing left to do for us in here, in Houdini, is select all these 3 output nodes and just hit save to disk. And after a bit of waiting, our outputs are done. We can jump back into Blender. Let's first of all get rid of this import right here. We don't need it anymore. And then let's now import our new exports. So again, file import, Alembic, and now let's select our paint cal, pause, and SCL like this. Now, once they're imported, we first of all have to find a way to combine them all into one object and to also convert our color and our SCL imports into a radius and a vertex color attribute. And then we also have to find a way to convert this in the end into a grease pencil object. So this is what I want to do next, and this is something that I want to do with geometry nodes. First of all, I'm going to create a new object with Shift A, and I'm going to go to grease pencil, and I'm going to select an empty grease pencil object. And this is later where my mushroom will be created. Next, down here, I should already have a new geometry nodes window, and I only have to hit new in here to create a new geometry nodes graph. And now our grease pencil object in here has a geometry nodes modifier, and we can build our setup in here. This first of all takes in our original grease pencil object and then simply writes it back out again. And to this grease pencil object, I now want to join in a new object, or mushroom in here. So first of all, I'm going to hit Shift A to bring up my nodes menu, and I'm going to search for join geometry, like this. Let's wire this in. This works just like a merge node inside of Houdini. And what do I want to merge in here is a new node, a node that comes with Blender 4.3. And that makes that whole thing possible. The curves to grease pencil node, like this. Let's drop this down. Let's wire this in. And now we have to find some way to grab, first of all, our positions, our actual lines, and pipe this into here. To do so, you want to just grab our object up here and just drag it into our node tree. Now we have an object info node, and that right object is already referenced in here. And all that we have to do is connect the geometry to the curves like this. Now we can't see much yet. Let's also turn off the visibility and the render visibility for all of our imports. And currently we see nothing. The reason that we're seeing nothing is that we have to deactivate instances as layers, and now we actually have some grease pencil curves. Of course, what's still missing are attributes, so let's create them next. For these, I'm going to use a node called store named attribute. So let's drop 2 of them down. Let's write them in here. And the first one will be a float on point level called radius. And once we add that in, now I have down here a slider where I can control the radius. And again, later I want to use my actual geometry import to control this value. And for the color, I want to select a type of color, again on point level. And the right name in this case is vertex_color. Now, what I want to do next is I want to bring in, for example, first of all, the scale object. And then for each point on this geostream, I want to find the corresponding point on this object right here, get its position, get the x-axis of the position, and this will then be the value that I want to pipe into this value field right here. Let's maybe make some more room here. Let's move this up out of the way. And let's first of all drag in our scale, get a new object info node. And now I want to grab a specific value from this object from a specific index. And I can bring this in by, again, bringing up the node menu, searching for index, and using the sample index node. So our geometry goes in here. And what this node also needs is the value that we want to grab. So this will be the position. And to grab the position, we're going to search for a node called position. We also need an index to sample from. And again, bring up the node menu, search for index, and this will grab the index from the current point that we're processing here and wire this in here. Now a couple of things left to set up in here. First of all, what we're sampling in here is a vector, and I also want to be able to scale my line thickness, and for this I'm going to search for a math node, wire this in, wire this up like this, and then set the mode to multiply, and for now set the value to 1. Give it just the original thickness. And now this is all we need to sample the radius, so we can finally draw a connection from the value here to our store named attribute here. And once we do so, we should see our line thickness in here working now. But we can sort of see it. To really see it, let's now also bring in the color as well. Now the workflow in here will be pretty similar to what we built in here. So in fact, I'm just going to copy these first 4 nodes. And I'm going to just hit Shift D to copy them. And in here, for my object info, select not the scale, but the color. Let's see what happens if we just wire this in to a named attribute node up here. And let's maybe also make some room in here. Move this out of the way. Let's bring this up a bit and wire this in. And first of all, we see nothing changing. The reason for that is we're in the wrong display mode up here. If we make some more room in here, we have these 4 round icons up here. These are the display modes. This is wireframe. This is solid shaded. This is actually shaded or material preview. And for some reason inside this geometry nodes viewport up here, we have to be in rendered mode. In every other viewport, it's enough to be in the shaded mode. But we can still see another problem. Our colors in here are clearly wrong. And the reason for that is since we imported our colors as positions, and Blender is a program where the z-axis is the up-axis, while Houdini is a program where the y-axis is the up-axis, our axis and therefore our RGB values were switched around a bit. So we have to fix this. And to fix this, we're going to go back to our color import down here. We're going to drop down a separate XYZ node, wire this into the output, and then right after it, a combine XYZ node like this. And our x-axis, our red values will still go into the x-axis, but now our z-axis will go into the y-axis, and the y-axis will go into the z-axis. However, we also have to negate the y-axis. So for this, let's drop down another math node. Let's again set the mode to multiply, and let's set the value that we're multiplying with to -1, and then wire in a y-axis into the first input and wire the output into the z-axis, like this. And now we can go from our combine XYZ back into the value, and now we should have correct colors. And this is pretty much the entire geometry nodes setup in here done. What I can do now is work on the final rendering. So for this, what I want to do first of all is bring in my original mushroom object. and have this sort of live inside my painted object. So I can't see it through my painted object like I can do right now. So for this, again, let's bring up the import panel by hitting either F4 or going to the file menu. I'm going to choose F4 and I'm going to import an FBX. And this will again be my Fly Amanita FBX. And this needs to be scaled up by a value of 10. So let's hit S on our keyboard to go into scaling mode. And let's simply enter 10 for 10. And now we have the correct scaling. And we can just hit enter in the end. Next, I want to work on the shading of this object inside it. So for this, let's go into the shading tab. And let's click new in here to create a new material. Let's hit Shift A and search for image texture like this. Let's vary this into the base color and let's select the right one. And again, this will be the Fly Amanita Albedo like this. And also what I want to do is I want to simply bring up the roughness to a value of 1 like this. Let's maybe go into the rendered viewport. Let's see how our rendering is currently looking. And it's currently looking, if we turn off the grease pencil strokes, quite gray because we don't have any lights in our scene. So let's fix this. Let's hit Shift A, go to light and bring in a sunlight like this. And let's just try to match the same orientation as we did in our Houdini scene. So I think in this case I want to rotate around the y-axis, so at R and Y. And let's type in 45. However, I think we need to rotate into the other direction. So let's add a minus. So rotate minus 45 degrees. You can do this in the viewport, or you can simply go to this tab right here and enter the right value in here. And now if we turn on our grease pencil objects again, this now does match our base object a bit better. You could also go into the World tab and use this option right here to add an HDRI. I'm not going to do this in this video, however, you can look this up. The last thing that I want to tweak in here is the actual look of my paint strokes. So for this, I'm going to select my grease pencil paint strokes again, and I'm going to go into the Material tab, and I want to change this solid line style in here to a textured line style. So let's select texture in here. And let's click this button in here to open one up. And in the scene file downloads under tags, you find one that I quickly created with Procreate. So let's bring this in. Currently, all aligns are black again. And the reason for this is we have to bring up this blend factor to make this blend with a point color. And then I also want to jump back to my geometry nodes node tree in here to go back to this point in our node tree and this multiply node in here, and if I bring this up, I can also control how thick my paint strokes are. A value of around 6 looks nice for this mushroom in here. Then let's go back to the material of my mushroom. The other thing that I can play with is this UV factor in here. This controls how much the paint texture is stretched, maybe a value of 150. And then finally, I also want a backdrop and a camera. So for my backdrop, I'm going to go into the Add menu or hit Shift A and go to Mesh and grab a plane. I want to scale this plane up quite a bit. Scale it up a value of 10. Let's rotate again by hitting R. X for rotating along the x-axis. And let's put in a value of 90 degrees. And finally, let's move it back. So let's hit G. You want to move along the y-axis. And let's just move it back a little, something like this. And again, you can do all of this also in this menu right here. Let's also create a new material for our backdrop. So let's go back into the shading tab. Let's make sure it is selected. Let's hit this new button in here, bring up the principled BSDF. And the only thing that I want to change in here is I want to make this emissive. So in here, let's make sure the color is set to white. And let's put in a 1 in here to just have a uniform white backdrop. And now all that's left for me to do is to add a camera. So let's hit Shift A, search for camera, or let's grab a camera. Where is it? Right here. Then to actually make it fit our view in here, let's go to View, View, align active camera to view like this. And we can also go into this side panel in here that I can bring up or close by hitting the N button or hitting this little button right here. And in here I want to go to View and click Lock Camera to View. And now if I rotate my view, my camera moves with me like this. Let's close this window again. Let's find a nice view. And now let's either go to render and hit render or simply hit F12. And since we're rendering with Eevee, this should go pretty fast. However, we can see a problem. Our shading in here looks all wrong. And Blender also tells us what we did wrong here. To render Grease Pencil, enable combined NZ passes. So we have to add one render pass. Let's close this window again. Let's go to our view layer or render passes layer. And let's click the Z button right here. And now if we hit render, what we see in the end is also what we're seeing in the viewport. And this is pretty much our entire rendering workflow done. One thing that you might want to play around with is inside the Grease Pencil menu. Down here under settings we have the stroke depth, and this is currently set to 2D layers, but you can also use 3D locations for a different shading style. But this is it for today, and until next time, it's cheers and goodbye. And if you like what we're doing, please consider becoming a patron of ours. Not only for supporting Entagma, but for access to in-depth courses. We're currently on the home stretch of finishing our first machine learning project on here. I'm super excited about that one. But if that's not your jam, you can find a lot more content about KineFX, Outvelum or Vex on here as well. Also, let me say thank you so much to all our existing patrons. Without you, this channel would not be possible. Thank you.